Hello, this is Professor Han. This is the third part of problem solving for Chapter 8, Resource Allocation. So in the previous part, we were able to complete allocation for the 7 activities here. So the project ended up with 14 periods. See that? 14 periods. Yeah, that's the mark. So then we answer a question here, 14. Second question, what is this resource loading sequence given the resource constraint? Now, check this mark. Yeah, we just had it log the sequence. So it looks like activity is the first one. And activity A is the first one. Then second is C, number 2. Then D, number 3. Then 4 is B. Yeah. Then F is number 5. Yeah. Then E is number 6. Then the last one is G. That's the sequence. A, C, D, B, F, E, G, based on this sequence. Question 3. What are the select times for all activities after resource constraint loading or scheduling? Here in the slides, I listed 2 criteria. So we cannot using the negative select to answer this question. Negative select is just an index to indicate the urgency of the activity. It cannot be real because in the real situation, the snack needs to be positive or at least 0. So here, given to get the right select now, given the new project timeline, which is 14 now, we look at each individual activity, given their schedule sequence, and ask 2 questions. Basically 2 criteria. The first criteria is this. If we delay activity, for example, A, to the next period, are we causing resource conflict? If the answer is yes, that means we cannot delay activity A further. That means its select time should be 0. If the question is, the answer is, oh, no problem, we could delay A to the next period, then we need to ask additional question. We'll get to that additional question when it's needed. That's first. Let's look at A. Let's say put the select as the last, all right? A. Can we delay A into the 3rd period? If we delay A here, right? A third period. That means 2, 2, 1, and then we would have to require 5 programmers in the 3rd period. That's beyond the limit. So answer is no, we cannot delay A. So the select time is 0 for A right away. We don't have to check the second criteria. So look at B right now. Can we delay B into the next period without causing resource problem? That's the first, into the next period. That's the first criteria. Looks like if we delay B into period 12, the 13th period, the 14th period, looks like the total, it adds up to 3, no problem. But we need to ask an additional question. Hey, is B allowed to be concurrently scheduled with other activities in the next period? Here, look at the network, the network diagram. B and G. B and G. B apparently is a predecessor of G. So basically when B is delayed, we have to delay G. B cannot be concurrently scheduled with G. Okay, so here, if we delay B, we have to delay G here, showing the last activity. So that means B cannot be delayed, even though resource-wise, it's no problem, but just cannot be concurrently scheduled with G because of the network diagram. Check on C. Can we delay C into this period 6 without causing resource problem? No, that would be 4, so it's 0. We cannot delay C. How about D? When we delay D to the next period, so D has been concurrently scheduled with C. So when we further delay D, we have still the total is 3, so no problem, right? This is okay. You can delay that and continue. Yeah, same with this period. Can we go beyond period 5 into period 6? No, because 2, 1, 1, that would add up to 4. So we cannot further delay. Then the select time for D here is 2 periods. Okay, activity E. Can we delay E into the next period? With resource-wise, not a problem, right? If we delay E, 1 plus 1 is 2, so not exceeding the resource constraint. Then if it passes this first criteria, we need to check the second criteria. Is E allowed to be concurrently scheduled with G? E and G. Check the network diagram. E and G. B, E, F, all the 3 activities are predecessor of G. E is not allowed to be concurrently scheduled with G. So when we delay E, we have to delay G. Therefore, E does not have select time. And F, the first criteria just failed because would add up, if we move here, it would add 4 beyond, which would go beyond the resource availability. So the last activity, we never delay the last activity, always 0 select time. Okay, so basically only activity D has 2 periods. All others, it's 0. Okay, list the critical path in the order after constrained resource loading. In this case, I would draw the critical path this way, following the loading sequence. Second, C. All right, D is not on the critical path because it has select time. Now they need to diverge into 2 paths. It has now B on the top, then continue to the last one, G. That's 1 critical path, all right? So I'm gonna write down here. So A to C to B to G. So add the length along this critical path. It is exactly 14 periods. Yeah. The second critical path, all right, is here. We could, after C, the critical path could go down to F. So we get F, then go up to E, then come back to G. So basically here, the difference is A still to C, but now it's to F and E and G. Yeah, this concludes the solution of Chapter 8 resource allocation problem. Thank you.